I'm Noah Schmeling from Biology 1951, and this is my presentation on Karl Friston. So, Friston early on had an inspiration to pursue science, mainly because his father was an engineer and his mother was a nurse. He also cited an experiment with magic mushrooms that made him think about how the brain works, especially when exposed to drugs like that. And then he had a lot of hardships moving all the time because of his father's career, which made him want to figure out how the human brain can adapt so quickly as he did. Some of his hobbies, he considers his job a hobby, computational neuroscience, and he loves his family. He's been quoted saying that many times, as well as reading, coffee, and a good smoke. I admire Carl Friston mainly because I'm also interested in neuroscience, and it has similar introduction to science. Mine was through my mom. I also think it's inspiring that he's continuing to do research even at his age. Friston's questions mainly tackle the concepts of cognition, consciousness, and action. And here's a little bit about his career. He went to two schools, the University of Cambridge and the King's College in London. And he's also a member of the Royal College of Psychiatrists and a professor of imaging neuroscience at the University College of London. This is going to be a little bit about Friston's 2017 research about active inference. So just a little bit so you can kind of understand. This is what I had to look through. It's very difficult to kind of figure out what's going on, but big things: free energy principle and probabilistic inference. Um, Essentially, I'll go to next. Friston and his team had the idea that since the brain works to reduce variational free energy, or essentially surprise, they like to make patterns, make sense of the world. If they could make a computer run that program and have similar results, they could reasonably make a theory that yes, the brain does operate with active inference, that being it's actively updating all the time, as well as limiting variation free energy. They use many concepts: mismatch negativity, theta gamma coupling, many more, which we'll kind of talk about in the next. And they found that for all of these, yes, it was appropriate to use active inference to group them all together, and the theory that limiting free variational energy was accurate. Here's a data figure from his 2017 publication about hippocampal navigation tasks. So essentially, um, in the top right, each dot represents, I guess I'll go to the next. Each dot represents a place where a unit fired, which represents a neuron. So in the top right, essentially each dot represents where a neuron fired responding to the reward location. In the bottom right, it's the same thing except there's dots at where the starting point is, showing neurons firing before they're even at the reward location and saying um, it's more spatial awareness and preconceived notion that, oh, this is where I'm going to go. And then the two columns on the left simply plot time on the x-axis, unit on the y, of how long it takes for these dots to make a response um, like a neuron would. And then some discoveries in the next steps of Carl Friston. He discovered the free energy principle. He continued working on it until he started working on active inference. He asserted that the brain likes to minimize free energy and uses active inference all the time. And he's learning to use this idea to apply to AI systems. Some final things. Friston has made a lot of contributions to society as a whole and neuroscience. I think he's inspiring. As I mentioned, he has similar background to science as me. He's in STEAM neuroscience, and I think from the interviews I watched, he seems like a very stand-up guy. And I just want to say thank you, and I appreciate you for listening. Here's some references, and thank you.